Hello class, today we're going to be doing the for loops. So if you go on to Student Computer Math folder on Box.com, open up the loops folder. And what we're going to be doing is downloading both these files. Now please realize if you left click on a PDF, it'll open up in Box. However, the way it opens up in Box is not perfect. So some of the things get moved, some of the things don't show up, and it also sometimes takes forever to load. So what I recommend doing is right click and download. And then when you download it, down here there's a little arrow. You can click show in folder, or with PDFs you can literally just open up. But then it'll still open up in Chrome, which you don't want to do. So to avoid that, when you right click and download, it shows up on the bottom here. You want to click on the arrow and click show in folder. So I'm going to right click, download the PDF. Right click, show and always open in Adobe Reader, that could work. Or you go show in folder, and then when the folder opens up, you just double click on the PDF. And what happens is it opens up in Adobe PDF, which is so much better. To get rid of this sidebar, if the sidebar is there, click on comment, click comment again, and it'll disappear. And then when you scroll it, it looks bigger and looks better, and everything's perfect. That's what you should know. Please realize the answers to this class are on there a little bit, so don't look at them. What you want to be doing is following along. XC means extra credit, XC means extra credit, and XC means extra credit. The rest of them you are required to do, so this one also is extra credit. So that means you need 1, 2, 3, 4, 5, 6 individual for loop lines and 1, 2 double for loops. So when we open up our Java code, we click the arrow, show in folder. And then over here I have the Java file. So I open up my Java by opening up BlueJ and having a project that's open. And then I'm going to rename this just because it works on mine, because it has to be different from the ones I previously moved in there. So I'm going to left click, hold, and drag it over. And when I open this up, for some reason, if you just change the name here and compile, it'll work. If you compile without changing the name, it won't work because the names don't match. It's just easier just to change the name. So this is an individual for loop, and then I have two system.print lines, which is basically the enter key, to separate this for loop from the next for loop. I do two, otherwise it looks like a solid one. Down below here is a nested for loop, which is a for loop inside of a for loop, which gives you the 2D array for loop output sort of setup. Let's go over these things real quick. Some background knowledge here. What we have here is on the left is the code, on the right is the code. What I mean by that is this is shorthand for I equals I plus 1. So I plus plus just increases I by 1. I minus minus decreases I by 1. I plus equals any number that I want to, 777, is the same thing as I equals I plus 777. However, programmers are really, really lazy, and by saving this one character, they will write it this way. But you can write it this way. Both will work inside the Java. Inside the for loop. So you can do addition, subtraction, multiplication, division. Over here, these bottom two, you're not going to be using today. This is greater than, less than, greater than equal to, less than equal to. You'll be using those today. So let's start with the first one. Oh, you need scrap paper, by the way. What we have here is a number. What you need to write down on your paper is what I write down, what this is, and then whatever I write down in these spots. You don't need to write down start, difference, divide, multiply, how many numbers. You do need to write down this and this though, because I want you to memorize this. You don't have to write out this because it's really easy to remember and you'll pick up on that. But those are the things I need you to write down in your scrap paper. If you ask me for help later on your programs, how to do these things, if you don't know how to set up the for loop, I need to see this written down on paper. Otherwise, I will not help you. Because otherwise, it's really hard for me to teach without just giving the answer. So our starting number, what that means is the first number, 25. That's our starting number. So we write down 25. 50% of the time, actually I don't know what percentage it is, most of the time the starting number is just the int I equals 25. That's usually what happens if it's easy. Next one is, what's the difference or divide or multiply? Difference is plus or minus. So to get from 25 to 50, I add 25. I can't divide to get there. Technically I could divide by 1/2, but that's mainly multiplying by 2. How many numbers are there? 1, 2, 3, 4. Oops, different color. 1, 2, 3, 4, so there's 4 numbers. That's the information that I need. To check my work, I also want to go from 50 to 75. How do I get there? I add 25, and I cannot multiply by 2. That will not work. 50 times 2 is 100. So that means I know that the way to set this up is adding 25 every time. So that means my I will increase by 25 every time. How many numbers? 4. However, I want to stop at 100. So it's I is less than or equal to 100. It's less than because I'm starting at 25 and going to 100. You could also write less than 101 if you wanted to. That would also be an acceptable answer. And technically that could be 101 to 125 if I really, really wanted to, but I wouldn't recommend doing that. Question?
Yeah. Why do you need the equal sign since the I plus equals?
Because I plus 25 is just an expression, it doesn't mean anything. The I plus equals 25 is an equation which changes the value of I. Good question. Oh no. Piece of crap. So, what do I output to the screen? With this one, I just output I. Because I is the value that changes, and I becomes 25, 50, 75, 100. You do not need to be writing this down. If you learn by writing down, write it down. You know best by how you learn. I'm not collecting that scrap paper, by the way, if that matters. I only care if you do learn. Now, that was the what I like to call noob way of doing it. Because it's easy and it's visual, but it doesn't look very good down here. Does everyone see that? You're jumping by 25. You can't really visualize the code and the output when you look at this. So what we're going to do is we're going to figure out how to visualize this. What's another way other than difference to get this to work? Well, we saw multiply by 2 work. So what times what equals 25? 1 times 25 equals 25. What times 25 equals 50? What times 25 equals 75? What blah 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 100? 4. Does this look like an easy array to write through a for loop? Yeah. What's my starting number? 1. What's the difference? Plus 1. How many numbers? So my int I equals 1. I increases by 1 plus plus. What's my maximum number? Less than equal to 4. Now, here comes the fun part. What I'm outputting is, I'm always multiplying by 25. What am I multiplying by 25 though? It's not 1, 2, 3, 4, it is I. So 25 times I. This way is required. to know. This way is not, but you can code it this way, but you need to be able to code it this way when I ask you to. Where I'm adding by 1, it looks very neat, and I'm timesing by 25 times I to get the output. This way up here is optional. You can do it that way if you want to, but you have to be able to code the bottom way. The next one, 0, 6, 12, 18, 24. What's our starting number? Let's do this together. What's our starting number? Shout out. 0, yep. So we take 0 and we write down 0. Please realize the only thing that needs to be written down is this text and whatever color text that shows up on your paper. How do I get from 0 to 6? Ooh. Times 6, yes. That's what you said, right? How else can I do it? Plus 6, you said?
Yeah, that's what I said.
Oh, sorry.
0 times 6 is 0.
So that's this. The times 6 doesn't work. Okay.
No, because 0 times 6 is 0.
Okay. How do I get from 6 to 12? Add 6. Can I multiply to get there?
Oh, yes, you can.
How?
Wait, no, you can't.
6 times what equals 12? Times 2. Huh. Okay. How do I get from 12 to 18? Add 6. And I can't multiply. It's a fraction, so we're not going to say we can. Okay, so we pretty much figured out the solution to it. How many numbers do we have? 5. I start at 0. I go till not 5. I go till 24. Less than or equal to 24. What do I increase by? 6 plus equals 6. And I output I. That's the easy way. Okay, everyone stop writing just for 2 seconds. I just want you to watch this. I'm going to go from the previous problem. I'm going to copy just these 4 things. Now, see, why'd you have to go and do that? I'm going to move these right into here. Everyone see blue text? Watch this. Prints out that. Let me show you why. How can I multiply by 6 to get 0? What times 6 equals 0?
0.
What times 6 equals 6?
1.
What times 6 equals 12?
2.
Blah, 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 18.
3.
Blah, blah, blah.
4. 2.
We have a new array, 0 to 4. Start at 0, go to 4, increase I, multiply by 6. What does this mean? This means that I can use math to translate almost any series of numbers into 0, 1, 2, 3, 4 and have it basically look like this output. Let's do another one. You can continue writing, sorry. Write this out. Bottom one's the important thing. Following our standard pattern, what we want to do is we want to circle the first number, call it our start number, 1. The difference from 1 to 2, I'm only looking at 1 to 2, by the way. I'm not looking at the other numbers. I'm not speculating. I'm literally just going through. Difference is plus 1. I can't divide, and I'm multiplying by 2. The next one, 2 to 4. I add 2. I can't divide. I multiply by 2. The next one, 4 to 8. I add 4. I can't divide. I multiply by 2. And then we ask ourselves, do we see a pattern? Yes, the pattern is multiplying by 2. So I circle it, so I know that it's there. I circle it so that I don't get into the other code. How many numbers do we have? 9. So we start our loop. We start with 1. We go until I hits 256, less than equal to 256. I times equals 2, and we output I. Hopefully you got that. If you didn't, it's perfectly okay. That's why it's a lesson. You're still learning. Question?
Why do we output I?
Because I is the value that shows up in this list. So we're actually changing I to be 1, 2, 4, 8, 16, 32. No. So the better way that I want you guys to program is this way. We take, and I kid you not, we take this code and we move it. I already know this time. I'll leave it in there. Uh-oh. Think I can do it? There we go. We move that code from the previous one right here into this one. And I say, do I want to start with 1? 0. Can I make it start with 0? Don't shout out, just think. My number is not going to be 4. It's going to be 9. And 9 from here. And then, of course, I'm not using 6. How can I get 0 to represent 1? How can I get 1 to represent 2? That's probably easier. I have the number 1 and I have the number 2. How can I get that to equal 2? What are all of the ways? First one is, whoa. We can multiply. However, this same method has to work when I have 2. How can I get 2 to equal 4? How can I get 3 to equal 8? Hold up. Hey. Let's look right here. Where can I insert a 3 here to get 8? When I start with 0.
The power of 1.
If I did I to the 2, does that equal 8 when I is 3? No. But here's the fun one. Can I switch it and say 2 to the I equals 8? What's 2 to the third? 2 times 2 times 2. 2 times 2 is 4, times 2 is 8. So let's look. Oh yeah, it is. Just hold on. I'll get to, I'm going to go over this again. Let's look at this real quick. 2 to the 0, does that equal 1? 2 to the 1, does that equal 2? 2 squared, 4. 2 cubed, 8. 2 to the 4th, 16. 2 to the 5th, 32. 2 to the 6th, 64. Now here's the big thing. This array right here is what we're looking at. So this is 0, 1, 2, 3, 4, 5, 6, 7, 8. Why did I stop at 8? I messed up on this code. This should be 8. Why is it 8 though? It's 8 because how many numbers do we have? Let's start with 0. 0, 1, 2, 3, 4, 5, 6, 7, 8. 9 numbers. As bad as this sounds, I want everyone to go count to 9 starting at 0. 0, 1, 2, 3, 4, 5, 6, 7, 8, and look at 9 fingers being raised. Because 0 counts as 1. That right there is going to be one of the concepts where you lose points on the test. Because think about it. What did I do? I messed up myself, and I've taught this 4 times. Or I did it on purpose, but that's a whole different story. So this is actually 8. How could it be 9?
Add 0.
Less than 9 would still work. So that's a really way to mess up your brains, to think about why that would work. But we'll get into that later. How do we write the code down here? 2 caret I. Caret, this right here, represents 2 to the I, which represents these numbers, how to get 2 squared is 4, 2 cubed is 8. Now, please realize you might still be lost, which is perfectly okay. We have lots more of these to do, but I'm going to show you one of every single type, and then I'm going to go through and show you more. Now, what I want you to write down real quick, if this red, if I add in plus, double quote, space, double quote, that code right there puts a space in between every output, which you will need to do in your code, and I'll show you that again later.
Wait, it puts a space between what?
So see how there's a space here and a space here? This plus double quote space double quote puts in this space. So that it's not every character, it's after every number. So you can legibly read your output. Let's do another one. This one's fun. Welcome to the headache.
What's a headache? Did the headache start like?
No, the headache should start now. It might have started earlier,
Yeah, it did.
but if it started earlier, you're going to have a headache on this one too.
Guys.
Answer that. Answer that to me about a minute.
Guys, I'm pretty sure at the end of this we're gonna be like, what's a headache?
Yeah, please quiet down. Get to work. Try this out. Write out the pseudocode. What's your starting number? What's your ending number? What's your minimum number? What's your maximum number? How many numbers are there? Can you add, multiply, subtract, or divide between every number? And actually write down those values for every step between every number. I make it sure. Yeah, so if I make this shot,
Don't move. Don't do anything. Right here.
then I have to do this work.
Yep.
Oh, look, I don't have to do it for you. Oh, what a shame.
Here, if I make it, then you should do it for me.
No, you already had a deal. One deal a day. Okay, yeah, sure. Yeah, here.
Can't shoot any. It's a fake move. See it faded it?
Yeah, standing over. There's no. It's impossible.
Is it?
Yeah.
Well, can't move. Can you sit down?
Try to help a friend.
Because that was your rules. Because you said I was standing and I couldn't move it. But now you're shooting, so it's not me.
We'll take your soda.
That you did our recording.
Nice try.
Guys,
Alright, let's get to work. Let's go. We got this. Try it out. You need to at least have that initial number, starting number, no matter what. You should get 116. Here's a question. Do you actually know why that came about? It's actually quite hilarious. It was archers in medieval days. You can look it up now, actually. You just get a referral.
It's a little messed up.
Just a little bit.
Wait, this I don't know. Oh my god.
Yeah, you can open up a calculator. Ooh. That looks good. That looks promising, doesn't it? From yesterday, hopefully you remember that 3 divided by 2 equals 1. Yeah.
Is that supposed to help?
Yeah, exactly.
What?
Let everyone have a headache. Except for me.
What's that mean? What does that mean?
3 divided by 2 is 1.
Okay, what does that have to do with anything?
So, also, what is it? Stop talking. 33 divided by
What?
Pi is 3.
20 also equals 1.
Pi is 3.
Why does that matter?
It matters for this for loop. 100%.
Square root of 2 is also 1.
Thank you for giving us a hand.
Alright, guy, raise a hand who's lost. Like, can't make any progress or could even guess.
No,
So, that means alright, so we know that 3 divided by 2 is actually not 1. What it is it's 1.5. However, because we're in Java it's considered an integer. So when we divide 3 by 2 we get 1.5, but it cuts off the decimal because we don't care about the decimal because the data type integer cannot hold a decimal, so we lose the value. So any decimal that we have, whatever that is, disappears. It gets truncated. It gets cut off. It's removed.
After our kids it's 1.65.
Yeah. So 1.65 would get removed. So by knowing this, when we go and do this, what's our starting number? 116. So we write down 116. How do we get from 116 to 58? We subtract 58, or we divide by 2, and we can't multiply. How do we get from 58 to 38? We subtract 20, and we can't really divide. Does everyone see that? And we can't multiply. How do we get from 38 to 29? Well, we subtract 9, and we can't really do those. Now, you should have also had 2, 4, 6. There is absolutely no reason why you couldn't have this on your paper. At this point in this class, you should have been able to do this. Just fill out those numbers, not get anything else. Just those numbers. Now, what you need to realize is, every single one of these numbers written down here has a purpose in the for loop. And if you don't write these numbers down and visually see, what can I do with 116? Well, our patterns don't work, so I'm going to go back to this 116. 116 to 116, how can I do it?
Divide by 1.
So we are going to refill out these numbers up here. I can divide by 1. So I can divide by 1. I can add 0, or I can multiply by 1. Does everyone see that? So let me make this a little bit cleaner. Now we want to go, and I'm going to change color so you can see it, 116 to 58. Well, we already did that. We subtract 58, we divide by 2, and we can't multiply. We can multiply by a fraction, 1/2, but that's multiplying. I mean, that's dividing, so we're not going to do that. How do I get from 116 to 38? Well, I can subtract a lot higher than 58, or I can divide by 3. And you should have a click or a light bulb pop on right now.
I'm so.
Okay, let's go to the next one. How do I get from 116 to 29? Divide by 4. Don't shout out the answer, please.
Oh. See.
Oh, it's magic. You know. How do I get from 116 to 23? Divide by 5. What are we looking for? We're looking for an array that looks like this. It's perfectly okay to be confused. There are a whole much more patterns that you got to pick up on. So, to get 116, to get these numbers, the end result is 116 divided by these numbers. So my answer has 116 divided by the number that changes. What's the number that changes? I. What value does I go up to? Well, we start with 1, 2, 3, 4, 5, 6. Oh wait, the 6 is right there. I less than equal to 6. What's my starting value? 1. How does I change? Plus plus. Now, real quickly. If I take these numbers right here and move them down, this plus equals is going to be on everything. Look at the differences. 1 just became the one that's back there. Do you see the one that's still there? So that's fine. 6 became 8. Well, that's because this is different length. Plus plus is the same. And instead of doing the 2 to the power, we're doing 116 divide. This pattern recognition is a skill that you need to have as a programmer. Keyword skill. Do you get skills in 20 minutes? No. So if you can't pick up on these patterns right now, that's perfectly okay. You're going to have plenty of time to practice this, plenty of time to learn this. This is only the 1, 2, 3, 4th one that we've done. Now, here comes the fun part. Which one looks hard to you guys? I'm going to do one more. So we have 1, 2, 3, 4, 5, or 6. Which one's hard? Raise your hand for 1. Raise your hand for 2. Did I give you one like 2? I don't think I did.
Guys, now we all know that 9 is the most difficult, okay?
I didn't give you one like 2, so let's do one like 2. It's actually not that hard. Now, please, give it a try. Try your best. Don't shut out the answer. Realize once you get the pattern, you don't need to write anything down. Pseudocode is just a tool to help you code. You have in your BlueJ for loop code. Type in the numbers there. Hit compile. And then when you run this, if you put in the new value, so right click, void main, hit OK. It will tell you the answer right here. Now, nothing shows up right there. And nothing shows up right there because when is I less than 4? when it starts at 5. Never. So if you change these numbers right here to your guess, whatever it is, compile, right click, void main, hit OK, it'll show up. Click options and you want both clear screen at method call and unlimited buffering checked. Otherwise you're going to come into a whole bunch of issues. So you probably need those numbers. Go ahead and start working on this. So basically before you clicked run applet, now you're clicking void main. Spoiler alert, what I'm going to write on the board will help you figure out the answer. Spoiler alert, so don't look if you don't want to see it. Okay, so let's take a look at this. We have 321. What's my starting number? 321. 321 is my starting number. What's the difference to get from 321 to 266? Negative 55. Can I divide? Not really. Can I multiply? No. How many numbers? 1, 2, 3, 4, 5. How can I get from 266 to 211? Subtract 55. How can I get from 211 to 156? Subtract 55. What this means is I already have my pattern. I want to start with 321. I want to repeat when I is greater than or equal to 101. Greater than because I'm decreasing I. So when I'm decreasing I want to keep on doing it until it's less than 101. So I want it to be true when I is greater than or equal to 101. How do I change I? Minus equals 55. What do I output? I. If I just made this where I would go, what is it? 5, 4, 3, 2, 1. The only difference between 5, 4, 3, 2, 1 and these big numbers is this would be 5, this would be 1, and this would be minus equals 1 or minus minus. And it would be the same exact code. This is just big numbers because someone in the crowd said 3, 2, 1. If we wanted to do it so this would be 0 plus plus. If we want to set it up this way, you will never have to do this. This is way beyond you. If I start with 321 and subtract the value of 55 times I would only have to go from I is 0, 1, 2, 3, 4, less than or equal to 4. This would also work. So if you wanted to do this 0 to 4 with increasing by 1, that's the formula to get it to work. Because every time I'm increasing by 55 more and I'm not changing I. However, this is end of year AP Computer Science level. If I wanted to put a space at the end of this code, I would do a plus, add a string, double quote, space, double quote. And this right here will add a space in between every number. If I wanted to add 2 spaces, I put in 2 spaces inside the double quotes. If you want to do an underscore, you can do an underscore. So it's literally plus sign, double quote, space, double quote. This is called concatenating a string. Concatenating, the plus sign, a string, this thing. Strings are coded by using 2 double quotes. Okay, what I want you to do right now is work on 1 through 6 in that order. Get it in BlueJ working. Please realize when you turn this in, it needs to have all of these on the same Java file, all at once. So don't delete your old code. So what I want you to do is get 1, 2, 3, 4, 5 to work on this one, and then 3, 2, 1 on this one, and then the next one on this one, so on and so forth. To make another one of these, you copy this, and you paste it right in, and you put in another one. You will need to, at the end of every line, go comment 1, 2, 3, 4, 5 with spaces to tell me what it outputs after every for loop. For the double for loops, I just need the first line. Whatever the first array is all I need. Please realize, if you need help on any of these loops, I need to see your pseudocode, which means I need to see on your paper 25, these numbers, and this number. If you have these things written down, I can help you learn how to do it. If you don't have these things written down, I can only show you the answer. So if you're asking on how to get to the for loop, I need these written down. If you have this written down and it doesn't work, I can help you, but if it's a logic error, I'm going to go back and say, I need to see your pseudocode. Because if you're doing it in your head doesn't work. Paper does. Write it down on paper, because then I can say, well, what's the difference? What's the divide? What's the multiply? What's your starting number? What's your ending number? If you don't have this written down, it's really hard for me as a teacher to teach you. Other than just give you the answer.